So in the sound realm, frequency is equivalent to pitch. A higher frequency corresponds to higher pitch. Okay. And amplitude, the size of the wave, corresponds to loudness. Okay? That part. That makes sense. So basically, why extremely loud sounds can, break the glass? Because glass can vibrate in response to air vibrations. Does that make sense to you? And it will be vibrating so violently that it will just explode. Okay, good. Let's talk about the ear. I have a model right here. You all have models. And we're going to start with the outer ear, and I'm going to put this on the board, no worries. So outer ear consists of two subparts, pinna and auditory tube. So basically what I'm trying to draw here is the direction of the sound. So sound, look, is focused by the pinna. This is why your ear has this weird shape, into the auditory tube. Okay? So this auditory tube, also known as external acoustic meatus, is full of hair and ceruminous glands, which are modified sweat glands that produce earwax. Okay? Now, which size of an object you can safely stick into your auditory tube? Anyone knows? What ear, nose, and throat doctors say about the size of an object that you can stick in your auditory tube. Anything bigger than your elbow, which means that nothing should go there. So you don't need to clean it. Earwax is good. It traps crap. Okay? If you ever looked into the auditory tube, it's pretty disgusting. Now, these vibrations of the air go through the auditory tube, and then they meet the first part of the middle ear, which is the tympanic membrane, which you know as an eardrum. Okay? Okay? In response to those vibrations, tympanic membrane vibrates itself. So here in the model you can see tympanic membrane right here. Okay? The part of the tympanic membrane that faces auditory tube is covered with skin. So if you look into the healthy ear, you will see that, healthy pinkish skin covering of the tympanic membrane. The inner part is covered, inside surface is covered with mucosa. Okay? So tympanic membrane vibrates. And you can see here that there's a bone attached to the tympanic membrane. This bone is called malleus. So vibrations transfer to this malleus, which means hammer. From malleus that is attached to the tympanic membrane, vibration are transferred to the second bone, second auditory ossicle, which is called incus or anvil. And from incus, they are transferred to the third auditory ossicle, which is stapes. Now, those little vials that I gave you, that are positioned on each table, they contain one of the auditory ossicles. Actual auditory ossicles. That's the actual size. So, stapes or stirrup is the smallest. bone in the human body. There is no other bone smaller than that. Okay. So now these are auditory ossicles. Now here's one interesting thing. Imagine that you are, so let's talk about problems, okay? Problem number one, really, really loud sound. Can the loud sound damage your tympanic membrane? Absolutely it can, okay? One of the sort of, well, we'll get back to how you can kind of protect. So now, if your tympanic membrane is shattered in pieces, that's it. It's gone. However, sometimes people can do damage, for instance, during diving. Sometimes if water goes into the nose, through the nose, can get into your ears, believe me, and it can rupture tympanic membrane. It's gonna grow back. Okay, that makes sense. It's not permanent damage. Now, if the sound is really loud for an extended period of time, for instance, you are at concert of Napalm Death concert in the first row. I don't know why. So they will. This auditory ossicles will vibrate constantly with a really high amplitude. Does that make sense? And that can damage them. So in order to constrain the vibrations, there are two muscles. One muscle is called tensor tympani. And it contracts and reduces the amplitude of vibrations for malleus. And the muscle called stapedius does the same for stapes. So far, we're good, makes sense? So basically, and yes, Napalm Death concert is the personal experience. So you go there, those muscles get really, really stiff. So now the sound that you hear isn't as loud. I mean, it's still very, very loud, but due to these muscles, the vibrations of the structures in the middle ear are restrained. Okay? When you come out of that concert, they're still restrained, and your hearing is kind of impeded. Now, another problem that's associated with middle ear, middle ear infection. Why? How does it work? Turns out that your middle ear is connected via a so-called pharyngotympanic tube or Eustachian tube to the pharynx. So this tube right here, this one, connects your ear to your throat. Okay? This is why, now think about the whole system. Your nose is connected to your throat. Your ear is connected to your throat. Therefore, ENT, your nose and throat. Right? So in children, this tube that is pretty inclined here is more horizontal. So when they have nasal infection or pharyngeal infection, okay, the discharge, the pus that's produced, can kind of make its way into through the pharyngotympanic tube into the middle ear and cause the inflammation and accumulation of pus. Otitis media is caused by and large by bacterial infections. Okay, so what are the options? Currently, as far as I know, it's American Academy of Pediatrics recommends to prescribe antibiotics, but to advise not to give them, because it's known that antibiotics are marginally effective. Basically, with antibiotic, day 5 after the onset of infection, with antibiotic, 89% of kids get better. Without, 84% of kids get better. So, basically what's told, if you don't feel better in 3-4 days, start taking antibiotics. It makes sense? In the olden times, I saw it with my own eyes. You can flush the ear, I think I was 9, and I saw a boy of my age, and I thought that the syringe was like that big. It was probably that big, still pretty impressive. And they were just flushing it with some antibacterial solution, and stuff was coming out of his nose and mouth. Thought, holy crap, thank God I don't have this. And in case of repetitive infections, you're going to have tubes, all heard about this, inserted in the membrane. When anatomy changes, when you grow, anatomy changes, you're not getting those infections, and tubes just fall out by themselves. Okay? And membrane fixes. That makes sense? Good. Okay, now, vibrations are still going on, and what's important? Frequency stays the same. Frequency never changes. Okay? Amplitude will change a little bit. And it will change right about here when stapes will transition the vibrations, transfer the vibrations onto the oval, through the oval window into inner ear. Okay? So, I think I know what I want to say here. So these vibrations will first, through the oval window, be transferred in what is called a bony labyrinth. Now, let's agree that we are talking about sounds in the hearing range, okay? So if that's the proper sound, it will go from bony labyrinth into the so-called membranous labyrinth. And then, interestingly enough, look, it'll exit through the round window into the middle ear. Does that make sense? So sound will kind of make a loop, okay? These vibrations, physical vibrations, the round window, both oval window and round window are covered by a membrane, and those membranes vibrate. Okay, we good so far? Now here's the deal. So the function of hearing is in the membranous labyrinth. Essentially, it's a hearing organ. We good? Kind of the pathway. Know the pathway, please. Know the pathway. Okay? There will be a lot of stuff. Orders, stuff like that. Okay? Functions. Now, if you have no questions, I'm going to heal this, and then we're going to chat about inner ear specifically. What is bony labyrinth? What is membranous labyrinth? What's in there? Okay?